Okay, I'd like to welcome everyone to the May seminar for the Western Center for Agricultural Health and Safety. We're really happy to have you join us. Next slide. I'm going to go through a few housekeeping items. As a reminder, this seminar is being recorded. All participants are muted. Please use the chat function to submit questions for the question and answer session at the end of the presentation. As Yahaira mentioned, Spanish interpretation is available. You can choose English or Spanish from the interpretation language section below. And that's that globe-like figure at the bottom. Select either English or Spanish. We also have closed captioning available. Select the CC icon below and click Show Subtitle. Next slide. I'm really happy to introduce Dr. Rob Atwill and Jennifer Chase to present on their research project. They're one of the Western Center for Ag Health and Safety's core research projects, and we've just really been happy to have them with us for the last 5 years, looking at occupational patterns of acute exposure to zoonotic pathogens, specifically among California dairy farm workers. And so with that, I'm going to turn the floor over to Dr. Atwill and Jennifer Chase for the rest of the afternoon. Thank you.
All right, well, thank you for all joining, and we're very excited to share with you some work we've done these past few years. Jennifer Chase, who will introduce herself a little bit later, she'll help with discussing the methods she used while out in the field and in the lab. But what we're going to talk about, as was just mentioned by Heather, is where on the dairy are dairy farm workers experiencing sustained high-risk exposures to the pathogens that are shed in the feces of infected dairy cattle, going from animals, the calves, up through the heifers, and then lactating dry cows, and then both cull and clinical cattle. So there are a variety of aims that this larger project tackled during the 5 years that it's been continuing. But I'm going to focus for this presentation on just the first 2 aims here highlighted in yellow, and that is which type of animal and at what production stage is it shedding one or more enteric pathogens that can make workers sick when they become in contact. So what is the risky animal, for example? And then what are those occupational tasks that put a worker in contact with that infected animal, particularly if that task makes you in proximity or for some reason exposes you to the manure. For example, if you get hit with a tail that's covered in manure, hits you in the face, you've had an acute exposure. Was there a pathogen or not? That's some of the data that we're going to discuss. So there's a large list of these microbial pathogens that we might worry about, particularly here in California. If we were in Africa, if we were in Southeast Asia, if we were in Europe, this list would be a little bit different. But certainly some key pathogens we're worried about on Western dairies here in the United States would be bacterial pathogens, such as Campylobacter, Salmonella, and pathogenic strains of E. coli. And of the protozoal parasites, at the top of the list would be Cryptosporidium Parvum, which is a very infectious, single-celled parasite that can create diarrhea or more serious illness. We won't discuss the possibilities of and helminths because this project could only tackle so many pathogens in X amount of time, and so we'll discuss those in the next sets of slides. The ways that we think about occupational risk when you contact manure, and are you likely to become infected if you inadvertently ingest a small amount of fecal material, is how many pathogens does it take to have a reasonable chance of infection. So this is some older data that was done for Campylobacter. Years ago, you could do studies where human volunteers would ingest a pathogen at different doses and to see what proportion would become infected. And then we can plot an infectious dose curve here. So you can see if you ingest several hundred of these bacteria, you have about a 50% chance of becoming infected. As you ingest 50,000, 60,000 in a small amount of fecal material, the probability goes higher. But if you look here, these experiments involving human volunteers never looked at low doses where of our occupational exposure occurs. Many of our workers, many of our veterinarians, many of our dairy owners are frequently in contact with manure that has low concentrations of pathogens. So we really have no idea the probability that prolonged contact with low concentrations of pathogens, how likely are you to get sick under these circumstances? And unfortunately, it's difficult, as you can imagine, to get human volunteers to ingest every single different dose of pathogen. So unfortunately, we're a little bit blind. With respect to this parasite, Cryptosporidium Parvum, again, there was a study done many decades ago where they ingested 30, they ingested 100, several hundred, up to 1,000 of these small eggs we call oocysts. And you can see it takes about 165 on average for 50% of susceptible individuals to become infected. I'm here in a school of veterinary medicine, and almost every year we have incoming veterinary students assigned to a diarrhea calf. And unfortunately, despite their best efforts, personal protective equipment, they wash their hands, they contract the disease from the infected calf because they're highly susceptible. It's their first exposure. So this parasite, there has been numerous studies done in California, both our group and others, and across the United States and globally, are quickly infected with this small parasite that's very infectious to humans. So you can see here a calf ranch, many, many young calves. You can see the fecal material. If this animal becomes sick and we're having to handle it, grab it, we're in intimate contact. Our boots will be covered. So what is the shedding pattern of oocysts or eggs of this parasite in the feces? And you can see here some older data. This was down in Tulare County. After just 5 days of age, our young calf begins shedding these oocysts. We have 10, 100, 1,000 oocysts, 10,000, 100,000, 1,000,000 oocysts. You can even see some calves, after a few days of infection, are shedding 10 to 50, almost 100 million oocysts in just a thimbleful or a gram of feces. So recall, I just mentioned that it only takes 165 to infect half of the people who are exposed to it. Here we're shedding 10 million oocysts in a small gram of feces. A calf will excrete maybe half a kilogram, it depends, per day. So that's 5 million of these eggs one calf sheds per day. So if you're assigned to be the calf feeder, the one who cleans the buckets, if you have to clean out the stalls or tend to these infected calves, you're going to be exposed to oocysts. So let's go through a mock example. Yes?
Can you hear me?
Yes.
This is Yahaira from the Western Center. I'm going to ask you if we can connect through our backup plan. There's an echo from your audio, just so that we can get the interpretation clear. So if it's okay, we can mute your current device, and then I will call you on my phone.
Okay. Can you hear me? All right, should I continue?
Yes.
So in this mock example, you can see an infected calf shedding 10 million oocysts per gram, and during worker handling, maybe a gram of feces is smeared on the hands, and after we wash them, there's a 99.9% reduction. So there's a small amount of fecal material left. What would be under your finger now would be 10,000 oocysts, even though you washed off most of the feces because the concentration is so high. There's still enough to create a high level of infection if you, for example, chewed your nail. In the milking parlor, it's a much older animal. And even though the workers are in close contact with fecal material, in this case, the cows would shed only 100 of these eggs per gram. We get a gram of feces smeared on your hands. You wash your hands. In this case, very few oocysts are present. So the risk is very different if you handle a calf versus the adult cow. So probably much of our occupational risk is in this low range where there's a low probability of infection. But because of sustained contact, or if the worker doesn't wash their hands, eats food, touches their mouth, they can substantially elevate that risk. So this project is trying to identify risky animals and occupational tasks that combine to create sustained exposure to risk of pathogens. That's what we're trying to find. I'll let my PhD candidate, laboratory manager, Jennifer Chase, explain the methods in the next couple slides, and then I'll take over again.
Okay, hi everyone. So we were awarded the funding 1 year late, but then that was okay. We got busy. We had a lot to learn during this project because our lab is not used to doing human-specific data collection, so we had to go through a whole process to get approved to do that type of work. And by the time we had everything rolling and collecting all our data, COVID happened. Next slide. So I'm just going to go over quickly what we did in the laboratory to analyze the samples that we collected. So we went on the farm. As Rob mentioned, we wanted to collect different pathogens. Of course, we didn't just want to focus on one because there's a ton of different pathogens in a dairy environment that could potentially affect humans. And so we selected 5. And the 5 pathogens that we selected were Campylobacter jejuni. We also went ahead and did Coli as well. Cryptosporidium Parvum. Then we also did E. coli 0157, Listeria monocytogenes, and Salmonella. And so when we used different types of media, of course, that were selected for these pathogens, but we wanted to also get not just a sense of if they were present in the animals, but at what concentration, like what Rob was mentioning earlier. So I designed an assay that can detect down to 3 MPN, which it's not really the same thing as a CFU, but it's similar, and up to 100 million MPN. So we had a very wide range of bacteria pathogens that concentrations that we could collect. And when I went out to the dairy, I decided, because I'm not from the dairy environment, I had a fresh pair of eyes. And so I wanted to look at different age categories of the cows. So I separated 5 major categories, as you can see on the top row here. We have calves, heifers, dry cows, lactating, and then I had another group. And then each one of those was subdivided into 2 further categories. So basically a pre and a post. So if you were a calf pre-weaned or post-weaned, or, sorry, I just lost connection. If you were a heifer, if you've never been pregnant or you were already pregnant, so your first pregnancy, if you're a dry cow, far or close off, and then lactating, high production versus low production. And the other category, just look at the clinical and the cold cows. Okay, you can proceed to the next slide, Rob. And so that is what we looked at for the pathogen side. And then we wanted to explore how the humans were interacting with the cows. And so again, I was new to the dairy environment, so I had to go out to the dairy and try to figure out what type of jobs that each worker was doing. And of course, based on the location in the dairy, they're going to have very different tasks that they're focusing on. And so I was able to split these major tasks, which I'll call duration events, so we could see them performing this task for some amount of time. And I was able to record that data for as long as they were doing that task. And then during that time that they're performing the task, they might perform what we would call protective or risky behaviors. So examples of high risky behaviors, potentially high risky behaviors that we observed were like touching your face. So I was surprised to see dairy workers that maybe did have a lot of feces on their hands touch their face, or maybe other risky behaviors like eating or drinking while you're on the job. That might have a very direct transmission route into your mouth. Where other times we were observing people washing their hands or changing their PPE, and we deem this as protective type behaviors over here. Thank you, Rob. And for like the indirect transmission behaviors, the middle group that we have here, this will be like if you touch a cow. So we don't know, that's very dependent on where you touch the cow. You know, that's just more general. So you might not get right next to somewhere that has pathogens on it. Or just because a cow is like whipping you with its tail, it might have the potential to splash some feces on you, but also it might not. And it just depends on how you respond in that situation. So we put that in the indirect. It's not like you're not directly putting feces in your mouth. There's some potential. You got to do some more work to get in there. Okay, I am done explaining that part of the presentation. Rob, would you like to proceed? Thank you.
So we need to take all this information, which animals are infected, and which occupational tasks put them in contact with those infected animals. And then are they doing additional behaviors that elevate that risk or reduce the risk, like washing your hands? We need a way to combine all this information into what we would call a zoonotic disease risk index, just some way to combine this information. So we will create a product of how likely are you exposed to a pathogen in a small amount of feces? How likely are you to contact an infected animal, multiplied by the rate at which you do your occupational task and the rate that you conduct these risky or protective behaviors. So let's look at some data. First, who did we study? This is the composition of the workers that participated in the study. As you can imagine, there was hesitation. So a wide range of different job categories were observed by Jennifer, a range of educational attainment. We had a diversity of ethnicity in our workers and about 80% male. Many of these tasks appear to have a short duration of how long they're at the job, while other jobs, they have been there for a long time. What did we see in the animals? We look at the different categories from calf to older to lactating animal of this parasite called Cryptosporidium. And in yellow are the high risky values. So 22% of our calves are shedding on average a high concentration of oocysts, 200,000 oocysts. Remember, it only takes 100 or 200 to make you sick. You see a small percentage of heifers and lactating animals shedding a high concentration of oocysts, but this low prevalence reduces the risk. So it's a high prevalence and a high concentration that creates high risk for the workers. If we look at E. coli 0157,
Many different animal classes are infected with this bacteria. Highest concentration occurs in the lactating animals. High percentage, high concentration means high risk. Salmonella is a different pattern. We have dry cows, heifers, and other, meaning in this case clinical, shedding very high concentrations in the feces, over 1 million bacteria per thimbleful. What about Campylobacter jejuni? We see a very high prevalence across all age classes of animals. A high concentration in feces occurs mostly in the calves and in the lactating animals. We see a similar pattern with Campylobacter coli, that the lactating cattle are shedding the highest concentrations. So these 5 pathogens create different risks at different times, depending on where the animal is in its life cycle, from calf to heifer, lactating, dry, and unfortunately, eventually cold. So we've covered the probability or the prevalence of these pathogens in these 2 tables that I just showed you. Let's look at the risk of contacting manure that has a pathogen. Just a little bit of math. I know many of you don't appreciate math, so this is 1 slide, 2 slides for those who appreciate math. Using the Poisson distribution, it will tell us the probability that manure has 1 or more pathogens given the mean concentration. And so remember, this slide has the mean concentration when an animal is infected. And so the probability of having no pathogens, when on average they have 4, is very low in this example, 2%. So the probability of having 1 or more is 98%. So we'll use this simple equation, 1 minus E to the negative arithmetic mean of pathogens in manure, this value that I just shared with you, in order to calculate this slide. This is, if you contact manure and the animal's infected, how likely is there to be 1 or more pathogens in a tiny speck? You know, the amount on the foot of a fly. And in red, I've shown you the high risk. In orange is moderate risk. Let's just focus on the high risk. For Cryptosporidium, we see that pre-weaned calves have a very high risk of having oocyst exposure to the worker, and then heifers that are pregnant and high lactating cows. We weren't able to DNA fingerprint or prove the species of Cryptosporidium in these animals because of the limited DNA, so that's why I've marked them with a C, that more work needs to be done. E. coli, very different. It's mostly focused on high lactating. So you see, if you're worried about crypto, you worry about calves, for example. If you worry about E. coli 0157, it's the high lactating animals. Salmonella is more spread out. We see pre-weaned calves, but particularly these heifers with their first calves, dry cows, and again, clinical animals. Campylobacter jejuni and coli both focus on high lactating animals, but for jejuni, it's in the calves. So we have this different risk depending on what type of animal and what type of pathogen. So if you ingest more feces, as I've showed, of course, no one wants to, right? We do it accidentally. But as you ingest more and more fecal material by accident, the risk increases substantially. In this case, there's an example of E. coli 0157. The risk for Campylobacter jejuni is very different. It's very high in pre-weaned calves. So very, very little feces from an infected animal can create the high risk of infection. Every pathogen is slightly different. We're trying to come up with a summary risk index. Where are pathogen risks occurring across the dairy to these workers who interact with different animals? So the next piece of information is, where do some occupational tasks consume more time on the dairy, and where do few workers focus their efforts on the dairy? This is where Jennifer and Krishna, a postdoc, followed a group of farm workers over time and cataloged about 64 hours. What exactly were they doing, whether it was summer, spring, different times of year? We had 24 different categories of tasks. Some focused more on lactating, like a milker or teat prep. Other will focus more on calves, like cleaning the hutches. So what we see is tasks associated with lactating animals consume most of the time. And second most energetic would be handling calves, dealing with calves, sick calves, a lot of time. Not nearly as much time with heifers or with dry cows. This is where proportionally more worker time is occurring to create contact with infected animals. Why they're doing those tasks? Did they exhibit risky behavior? Answer the phone like I'm having to do now. Did they touch their mouth, rub their eyes? Did they frequently get splattered with manure? So again, we broke these risky behaviors, protective behaviors into three categories: direct, touch face, mouth, eat, drink; indirect or less risky, spray the hose, use your phone, touch the side of a cow; and then protective might be wash hands or change your PPE. Where did workers really use their phones a lot, right? Or they touch animals a lot? You can see in the milking parlor, pushing cows, teat prep forces the worker to be in close proximity and contact the animal. So we have additional risky behaviors occurring with these tasks. We have some calf tasks that occur. So it's not just your occupational task, it's what happens while you do that task. So now let's combine all the information together. Where are the infected animals? Do they excrete a high number of pathogens? Do workers spend a lot of time with those infected animals? And why they're doing that, do they exhibit risky behavior? Maybe the administrative controls aren't as good as they should be on this one dairy, and we need some enhanced training on do's and don'ts to minimize, and that's what this project's about. So let's look at E. coli 0157. We have those 24 occupational tasks. We've combined all the information together to come up with a risk index, and I've put in red highlight highest values. So the absolute highest values, E. coli 0157, occur in high lactation, perhaps metabolically stressed dairy cattle. They're producing a lot of milk. They're losing weight. So they're shedding E. coli 0157, and the workers have to spend a lot of time, because that's one of the profit-making machines of the dairy, is producing milk, of course. Lots of time in the milk parlor or maintaining the equipment. E. coli 157 lactating cows. How about Campylobacter jejuni? Well, the highest risks appear to also be lactating cows, so we're starting to see a pattern for our second risky pathogen. But we picked up a little bit of calf exposure. Maybe you have to handle an infected calf. You have to hand feed it because it's weak and had diarrhea. It needs supplemental fluids. So not only lactating cows, but some calves create Campylobacter jejuni exposure. What about Campylobacter coli? All of this information points to milking parlor, particularly bringing cows up and taking cows back from the milking parlor. So you're seeing a pattern, right? Campylobacter jejuni, lactating cows, some calves, E. coli 157, lactating cows. How about Salmonella? It's very different. It's not the lactating cows. It's these clinical that create some of the highest risk. We get a little bit of calves. We have our pregnant heifers. Maybe they're a little stressed. And Salmonella is taking advantage. So Salmonella is more dispersed across the dairy. Not the one parasite. Cryptosporidium Parvum, of course, it's heavily focused on our pre-weaned 1 to 60-day-old calves. This is very consistent with the literature. Cleaning hutches, sick calves, preparing feed, cleaning the milking buckets. There's also a risk with high lactating cattle, but we need to DNA confirm the species to prove it's Cryptosporidium parvum. So don't worry about crypto yet in lactating cows, but we have a high degree of confidence due to earlier work we've done that this is probably 90% a species of crypto infectious for humans. So what about this weight? Why did we do this weight of risky behavior? When I say 10, 1, and 0.1, what we mean is those behaviors that were risky, that you touch your face, we magnify their impact in this index by 10. You get a neutral weight if you just touch the animal, and you get a low weight if you wash your hands. So I think this was entirely made up, and maybe we need different weights for these risky behaviors. We want to highlight where does risk occur. So if we changed, this is a slide I showed earlier. I know it's a little hard to read, but it's just the pattern. This is a weight of 10, 1, and 0.1 risky, neutral, and protective personal behavior. If we do just 2 times 1 and 0.5, it's the same pattern. The weight really doesn't matter, so it's probably arbitrary. The other technical question is, how do we model the probability when you touch feces? How likely is it that there'll be a pathogen there? And I showed you that equation earlier. What's the probability that 1 or more pathogens are present when you touch a small amount of feces? But then you have to multiply it by the probability that the animal's infected. Without going into the math and drive you crazy, a different way that we can model the risks is with mixed manure. And mixed manure will occur, for example, in the lagoon or in a pen. If you have to clean out the pen, obviously many animals are defecated. So in that case, the pathogen gets diluted, if it makes sense, by all of the uninfected animals. So in this case, I can't show you a million tables. I'll drive you crazy. But we recalculated our risk index for mixed manure when there's all the calf manure that's been mixed in a slurry, and you're the one who's assigned to go clean it up. And because of the dilution, lactating cows become a lot less important, but dairy calves still become the leading source of occupational exposure to this parasite. In summary, all the pathogens together, where do we have risky animals, workers spending a lot of time with those risky animals, and perhaps they're practicing some risky behavior, touching their face, eating and drinking while on the job? Of course, you get hungry, right? We all get hungry. One of the real hot spots, as I've shown you with multiple pathogens, is in the milking parlor because of the variety of pathogens that are shed by lactating, particularly high lactation, perhaps metabolically stressed animals, and our young calves. Strongly driven by Campylobacter, but you saw a series of other pathogens infecting our young calves and forcing the workers to deal with them because we want to deliver appropriate health care. We care about the health of the animals, of course. You have to work with them. So I expected, I'll admit, that calves were going to be a hot spot for dairy workers to be exposed to pathogens. But for me, maybe some of you expected this, the high lactation cows was not an area on the dairy that I expected to create multiple pathogen exposure. So I think this is an important area for future focus and to think about training, some extra administrative controls or engineering controls to make sure those who are working in the parlor are not exposed to a wide variety of pathogens. E. coli 0157, Campylobacter jejuni, Campylobacter coli. There was some Salmonella shedding, and then possibly human infective Cryptosporidium, all occurring in those lactating cows. We have long hours of worker contact. This is the profit machine of a dairy, right? It's a business. We're proud of our dairy here in California. But we also observed while workers are milking the cows and all the associated tasks, teat dipping, hosing down the parlor afterwards, everyone wants clean milk, that elevates the risk. And it puts the worker in close proximity or we're creating aerosols. So here you have the lactation curve, milk production in green, this is in months. So we have multiple months. Each dairy cow is in high lactation, very productive animals, the Holstein. They can't eat enough to sustain their weight and they lose weight and then finally gain it back in late lactation. Something in the physiology is encouraging animals to shed multiple pathogens, become infected, and create a focal point on the dairy of worker exposure. This to me was something exciting and new and possibly of concern, something that we should look into in the future. And with that, I'm happy to answer any of the accumulated questions.
All right, thank you so much, Rob. That's fabulous, very interesting. And I know I am typing questions away, but I want to make sure that all of those of you who are joining us today, please feel free to put questions into the chat and I will add them to the list. Okay, so one thing that you might have discussed some at the beginning, but if you could reiterate, can you talk through some of the health effects that humans experience being exposed to these different pathogens for those of us who are a little bit less familiar with exposure to the different ones that you mentioned?
Almost all of these pathogens can obviously create a variety of gastrointestinal distress symptoms, discomfort, diarrhea, lack of appetite, vomiting. If they have the appropriate genes that are highly virulent, it can become a very serious infection in a variety of these. Many of us have heard about E. coli 015787 and the additional clinical symptoms that occur with a serious infection that, unfortunately, a small proportion can lead to death, right? If untreated or if it's a severe infection. But typically these cause your diarrhea type food poisoning disease. And without getting all into some of the more disgusting bloody stool symptoms, that's what you would be looking for.
And did your study collect that information from participants, from workers, or were you looking only at the presence of the pathogen?
We did not collect clinical information on the workers. We wanted to, but it just creates a certain challenge of acquiring personal health information and that type of information. So the clinical symptoms, is from other published literature about the impacts you see in humans. Dairy workers, I'm a veterinarian, we develop some degree of resistance to some of these pathogens. Well, hopefully the clinical symptoms aren't as bad in occupationally exposed because we have immunity, but we all have problems with our immunity sometimes. We're psychosocial stressed for a variety of reasons, become susceptible, and may become infected and become clinical.
Thank you. And we have a question. Did you find any Listeria monocytogenes?
Great question, because you noticed we didn't discuss it much. We found very little Listeria in the fecal material of the cattle. You do find it in the broader dairy environment from prior studies, but we didn't show the Listeria data because the prevalence was extremely low. So I guess that's good news from a occupational exposure to the fecal material of cattle.
Great, thank you. Okay, so engineering controls are obviously the most effective at protecting workers. Have you seen any examples of engineering controls in dairies that might be effective at reducing exposure to some of these pathogens, especially around lactating cows?
I think the dairy industry, at least here in California, and I'm extrapolating, and I'm a veterinarian, so I only see what I see, but I think we need a lot more effort at both compliance and perhaps designing the dairy infrastructure to be a little more protective of fecal exposure. So you see the aprons on those slides that I showed in the milking parlor, but you don't see, and they may be unpopular, right? But maybe a face mask that we've seen those who didn't want to wear a covering on their mouth, they instead used a face shield, right? We have to use those here on campus. Maybe we're worried about aerosolization. There might be some relatively simple and inexpensive interventions to cut the risk substantially from at least aerosolized small amounts of fecal material.
Thank you. Another specific one about, let's see, you can tell which ones are kind of coming from me, from the exposure, from the worker sort of exposure, and then which are coming from the audience because of the different kinds of experience and expertise. Did you do any antibiograms on those isolates, especially Salmonella?
We didn't explicitly do antimicrobial resistance patterns, which of course would be very interesting, but I can say there are many parallel projects occurring here at UC Davis and elsewhere on the antimicrobial resistance patterning of many enteric pathogens from not just dairy cattle, but let's say livestock in general. We have multiple other projects, but within this project, we limited solely to pathogen quantification, prevalence characterization. So, but great question.
Always more research to be done, right? Okay, so you said that you were a little bit maybe surprised, or really the lactating cows stood out as the riskiest or the highest risk profile on the dairy. So could you talk a little bit more about why you think that they ended up being why the most pathogens were shed there, and what might be going on?
I can only speculate. It's a little outside of my direct scientific experiments. It's an internal medicine, immunological type of a question. So I can only speculate that the metabolic demands of high lactation and the inability of the cow to keep up, and as a consequence is in a negative energy balance, losing weight, creates the conditions of susceptibility that allow the lactating cows to become infected, and the pathogen amplifies in their gastrointestinal tract. And we're observing the final product, these high concentrations. Because, you know, why wouldn't it occur in the dry? Why wouldn't it occur in the lower lactation animal, as I showed? They'll spend months producing less milk. They're in positive energy balance. Clearly, they're in a pen with infected animals, perhaps. They don't become infected. So maybe their resistance has become stronger. I think that's a very generic, perhaps faulty explanation, but that's my assumption.
Jennifer, maybe this is one of your future research directions. So another factor that I'm wondering if you have thoughts on whether it makes a difference is whether or not different types of dairies or the way that different dairies are built themselves, groupings of cows might make a difference in the way that exposure occurs.
Again, a lot of work has been done on pen side, cow side risk factors for some of these pathogens, and how we organize cattle, clean the pens, the hygiene, the nutritional composition of their feed. So there are probably, depending on the pathogen, a variety of, you know, who knows how effective, but recommendations, for example, directed towards Salmonella or E. coli 0157. Sometimes it's difficult. Like the Cryptosporidium Parvum is intensely focused on pre-weaned calves. It is highly infectious for young calves, and it is difficult to create biosecurity. But there's different designs where we keep the calves in separate plastic hutches. Maybe more common where it's cold on the East Coast. We see that in upstate New York. But in California, we have maybe wooden constructed 3-in-a-row calf hutches that are open to the air where the flies can easily transmit Cryptosporidium between calves. Calves can lick each other. They can express diarrhea immediately adjacent to each other. Perhaps that's not the best design to minimize calf infection. There may be other production-related reasons why many dairies use the classic wooden hutch here in California. Some are on raised wire. There's animal welfare concerns, perhaps keeping a young animal on wire cages instead of on the ground, but the fecal material can drop through the wire cage. And if you have water flow underneath, it'll move it away. So it is an area of active research. It's not my direct area, but I think it's a very valid area. What can we do on the animal side to minimize infections in the first place, which makes a lot of sense.
And are there similar kinds of opportunities for the lactating cows as well? I mean, you talked about the calf setup, that the same would be true on the lactating cows.
I know what we often see here in California, at least on our larger dairies, is they're group housed by their production. You know, and it's up to the dairy to decide, do we want 3 different production strings, high, medium, low? Maybe they feed them differently. They administer slightly different care. But the group housing of production-related animals creates a challenge to minimize infection from animal to animal. They share the feed trough. They share a water trough. Maybe today I want to sleep in my neighbor's area and not in my area, so we don't always get the exact same stall. You know, maybe we all want to be in the corner stall where it's windy and cool. I don't know. I'm not a dairy cow. But it can be difficult in these high-density animal operations, such as a dairy. If you put them out on pasture, again, I'm just speculating, they're exposed to different pathogens, but maybe there's a lower concentration. So dairies are of different design depending on where you are in California. Small dairies, pasture exposed versus dry lot dairy can influence the infection dynamics of animals.
Thank you. As a reminder, we can take a couple more questions. If you have any, please put them in the chat. So while we continue to see research coming out around engineering controls, what's the advice that you would give to growers, dairy growers, dairy men, I guess, I apologize, and women, and farm workers who are out, you know, hopefully not being exposed to these pathogens. What steps can they take? Because I think it's powerful to see the dirt and grime under the nails. So what else can they do?
I know we hesitate to put all the responsibility on the worker, and I think we can strengthen our training programs, encourage compliance. We can eventually, it's going to be a lot of work to redesign dairies to minimize enteric pathogen exposure, because there's a lot of focus on production, right? These are businesses wanting to make money by selling milk to consumers. But for those workers who want to minimize their risk for whatever reason, don't want to bring it home to your family, you don't get infected yourself, there's a lot of PPEs that could be used. It's going to be inconvenient given the challenges of working in the dairy environment. As I mentioned, the face mask, personal hygiene, washing your hands, everything we heard about COVID. Don't touch your face, don't touch your nose, be careful, don't chew your nails. I know, I do this all the time when I'm working, and you just smeared some feces on your lip, and what happens next? You lick your lip, and you just ate, 50 oocysts, and you didn't even know it. So being mindful that there's a wide variety of pathogens in fecal material, and to just try and minimize oral exposure, particularly to what's on your hands and your clothing. Whether we're changing our clothes twice a day, whatever it would take, changing X gloves, the face shields, I think there's a lot a worker can do of common sense to minimize exposure to these enteric pathogens.
Great, well, thank you. Right, I think that COVID has taught us that we are constantly touching our face. We wear our mask down below our nose and down on our chin, all of the things that we're not supposed to do. Okay, well, with that, I just really want to thank you, Rob and Jennifer, for joining us today. We're really thankful that your project has been part of the center for the last 5 years. And I'm thankful that you were been able to proceed. I know that COVID really made it difficult to keep collecting the data that you needed to collect. And I'm glad that you've been able to progress with the work. So thank you, and thank everybody for I thank all of you for joining us today. We have one more seminar for the year next month, the first Monday in June at 4 p.m. We will have a graduate student talking about their work on musculoskeletal disorders. So please join us then. Have a great day, everybody. Bye.